Introduction to Matrices. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. The knowledge of matrices is necessary for various branches of mathematics, and in their simplest form, matrices are one of the most powerful tools to store information. Probably you have been using matrices for many years without realizing it. You have already seen tables like these. These tables are examples of matrices. A matrix is a rectangular array of numbers arranged in rows and columns. Matrices are denoted by capital letters, and it's usual to put square or round brackets around a matrix. Now let's see how to use matrices to arrange data and store information. Let's see how it works. Two softball teams submit equipment lists to their sponsors. Women's team needs 12 bats, 45 balls, and 15 gloves. The men's team needs 15 bats, 38 balls, and 17 gloves. Represent this information in a matrix. We can arrange these data as follows. We have two teams, women's team and men's team. And we have three types of equipment: bats, balls, and gloves. This table has two rows representing women's team and men's team, and three columns representing bats, balls, and gloves. So we can write this table as a matrix. The first row represents the women's team. The second row represents the men's team. The first column represents the number of bats that each team needs. The second column represents the number of balls that each team needs. The third column represents the number of gloves that each team needs. We can denote this matrix by a capital letter. We can choose the letter B, for example. The number of rows and columns that a matrix has is called its dimension or its order. By convention, rows are listed first and columns second. Thus, we would say that the order of the matrix B is 2 by 3, meaning that it has 2 rows and 3 columns. You should notice that the order of a matrix tells its size. In 2010, an elementary school in Brazil had 180 students and 38 teachers. In 2011, the same school had 903 students and 40 teachers, while in 2012 the numbers of students grew to 987 and teachers to 43. Represent this information in a 3 by 2 matrix. The matrix must have 3 rows and 2 columns. And when we look at the data, we have 3 years and 2 types of numbers, students and teachers. It seems an obvious choice that the rows represent the years and the columns represent the number of teachers and the number of students. We can arrange these data as follows. This table has 3 rows representing 3 years and 2 columns representing the number of teachers and the number of students. So we can write this table as a matrix. The first row represents 2010, the second row represents 2011, and the third row represents 2012. The first column represents the number of students in each year. The second column represents the number of teachers in each year. We can denote these matrices by a capital letter. We can choose the letter A, for example. The order of the matrix A is 3 by 2, meaning that it has 3 rows and 2 columns. A matrix is a rectangular array of numbers arranged in rows and columns. The numbers are referred to as the entries or elements of the matrix, and each element in a matrix is identified by naming the row and column in which it appears. In general, we can write a generic matrix A as follows. Matrix A equals Aij m by n. By convention, rows are listed first and columns second. So, following the convention, first subscript refers to the row number and the second subscript to the column number. The matrix A has m rows and n columns. The numbers Aij are referred to as the entries or elements of the matrix. Aij refers to the element in row I and column j. Let's see how it works. Write the matrix A whose elements are given by the formula. We know the order of matrix A is 2 by 3, so the matrix A has 2 rows and 3 columns. The matrix A can be written as follows. It's given that Aij is 2i minus j. Putting the values in place of I and j, we will find all the elements of matrix A. To find the entry A11, we replace I with 1 and j with 1. A11 is in first row and first column. To find the entry A12, we replace I with 1 and j with 2. A12 is in first row and second column. To find the entry A13, we replace I with 1 and j with 3. A13 is in first row and third column. To find the entry A21, we replace I with 2 and j with 1. A21 is in second row and first column. To find the entry A22, we replace I with 2 and j with 2. A22 is in second row and second column. To find the entry A23, we replace I with 2 and j with 3. A23 is in second row and third column. Now we write explicitly the matrix A. Given that C equals Cij 3 by 2, whose elements are given by the formula. Find the element in second row and second column. Find the element in third row and first column. The matrix C has 3 rows and 2 columns. But in this example, we don't need to write explicitly all the elements of matrix C. In item A, just find the element in second row and second column. Replace I with 2 and j with 2. In item B, just find the element in third row and first column. Replace I with 3 and j with 1.